Everyone is happy and healthy and doing fabulous. Okay, we are going to use this program, it's called GeoGebra, to look at dilations a little more closely. So in the previous lesson, we learned that dilations create a shape that is similar to, uses a scale factor. Here it's called the dilation factor, but that's okay. That's because that's what they've chosen to use. But it uses the scale factor in order to change the size of the shape. So we need to remember that this is asking us to change the size of the shape. So the sides will be proportional using the scale factor. You can set up a proportion for each of them. So you can start with the original over new. We're going to use this as kind of our setup. And if we're doing it a scale factor of 2, the original is going to be at 1. The new scale factor would be 2. And we would look at each of the side lengths and we can actually set that up and solve it that way. Okay, fabulous. But really what's happening? How do we do this if I were to ask you to do it the long way? Okay, so let's look at a couple things first, and then I'd ask you what you would need to do and what you need to do based on the standard. So let's first look, here's our dilation factor. If we look at the dilation factor as being 1, that means it is the exact same size as the original image. Everyone should be able to see that. In fact, if I change the size of the original shape, the other shape changes as well. If I change the center, please notice that the shape stays the exact same. Doesn't matter, because a dilation factor of 1 means it's the exact same size. If the dilation factor is less than 1, please notice what is happening. If it's less than 1, then the shape gets smaller and smaller and smaller and smaller and smaller. It gets smaller and smaller and smaller. I was hoping that I could zoom in, and that didn't help at all. Okay, it's the writing that's causing the problem. So we can see it's getting much smaller, 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 smaller. Okay, that makes sense. And so anything, a scale factor, so dilation factor, scale factor, those are interchangeable words. Everything between 0 and 1. So it's going to be less than 0, or it's going to be greater than 0, but less than 1. Everything in that range is going to make the shape smaller. It's still proportional, but it makes it smaller. So we could make the assumption that anything bigger than 1 is going to make the shape bigger, even if it's a decimal. Even if it's a decimal, as long as it's greater than 1, it is still going to make the shape larger. And yes, it moves away, but it is still larger. Now there's one easy way to tell what the new coordinates are going to be. You take your dilation factor and look here, this one is 4, what is this one? What do we do from 4 to get 12? Oh, we multiplied it by 3. Wait a second, that's our dilation factor. And if you look at the other one, the other point, it's 5. And what did 5 become? It became 13. So in order for 5 to become 13, we also multiplied by 3. Oh wait, which is the dilation factor. So the easiest thing to recognize is that you are just going to multiply each of your coordinates by the scale factor to find the new one. So if I'm asking you to dilate it to a scale factor of 3, you can see that you're going to multiply each of the original coordinates times 3 to find it. If I asked you to find the new coordinates for a scale factor of 0.8, all you do is multiply each of the points times 0.8. That's it. It gets even easier. Well, not really. Now, if I were to ask you to draw this, if I were to only give you the first one and say, okay, draw it, this is what's happening. What's happening is a imaginary line is being drawn from the center, the point of dilation, out. And so it is making from this center to this point of dilation. Yes, and it has to be a straight line. That is maintaining that the angles are the same. So this angle would then be the same as that angle. It's using similar angles. But you would measure, draw your 3 lines away from the center of dilation. And then what I would find easiest would be to find the length of, say, this side. And if this side is 6, and I wanted to make it larger, so I wanted to make it to a scale factor, the original side length was 6, I would like to do it to a scale factor of times 2. So the new side is going to be 12. You're going to find the space out here where that side length is 12. And then you can connect the dots subsequently. That's if you were doing it by hand. Now, luckily, the standard simply says to experiment with this and try it. So, for your test, I'm going to ask you to experiment. I'm going to give you this website, and I'm going to ask you to answer a few questions by playing on this website. You're going to print your screen, you're going to show me that you've played with it, and that's how you're going to show, because it's verify experimentally is what the standard says. Verify experimentally what's happening. This is an experiment, it's a technology experiment. So I'm going to ask you to verify that experimentally. So, in conclusion, if I ask you to dilate given a point, so if I give you a point and I say dilate to a scale factor of 1.5, all you do is multiply both of those coordinates by 1.5. In fact, you're going to multiply all of the coordinates by 1.5, and it's going to plot those points in the correct spots. If I said what happens to the shape, you could describe it. You could say it gets larger by a factor of 1.5. If the number is less than 1, you're going to still do the same thing. You're just going to multiply by a decimal, and it will give you the new coordinates. But also keep in mind that If it's less than 1, the image is getting closer to the center and is getting smaller. If it is greater than 1, it is moving away from the center of dilation. And so if I move the center of dilation, my other image moves, because remember what we've done is just connect lines from the center to each of our images. So that doesn't change. But what I want you to understand is that a factor greater than 1 makes the image bigger. A factor less than 1 makes the image smaller. In order to find the new coordinates, you simply multiply each coordinate by the dilation factor, and being able to sketch an idea as to what they are.